All right, welcome to the conference on graphing square roots and cube roots. This is going to be a two-part series. In part one, which is this video, we're going to talk about graphing the square root. And in part two, we'll talk about the cube root. So warning, vital information to scoring well in your next test is contained in this video. Be sure to have your note sheet and your worksheet out so you can complete the worksheet after and take notes as I go through this video. So let's go ahead and jump in. Again, we're going to take a look at graphing square roots. All right, so first thing you have to do is take a look at the parent function of square root. So f of x equals square root of x. So let's keep in mind that f of x equals y. So this is really the same thing as saying y equals the square root of x. So don't let the f of x throw you off. Next thing I want to take a look at are what are possible values of x. So what is our domain? Can you take the square root of -1? Well, it's I, right? So it's not real. We're only going to be dealing with real numbers. So we can take the square root of 0, which is 0. You take the square root of 1, which is 1. So we're going to be limiting ourselves to non-negative numbers, where the domain is going to be x greater than or equal to 0. So to find the domain in other graphs, we'll always take whatever's under the radical and set it equal to greater or equal to 0. Okay? All right, so we've already got 2 points, right? 0 was our first possible point, and then the next one seemed natural to pick 1. So I'll go ahead and fill these 2 points in. 0 is 0, and then 1 and 1. Well, someone might say, well, it's 2, 2 on the graph. I see a pattern going. Well, let's see. What's the square root of 2? Is that 2? No. What is the square root of 2? Well, if I pull up my calculator, square root of 2 is negative 1.41. Nope. Eraser. So this is approximately 1.41. Can I graph that? Yeah, I guess I could. But it's a little harder than an integer. So again, one might say, well, that's square root of 3. Well, again, I pull up my calculator because that's not a perfect square. And if I look at the square root of 3, it's approximately 1.73. Again, could graph it. Probably won't be very accurate. So when we look at good points, we want things that will evaluate to either an integer or maybe something easy kind of fraction like a half or a quarter or a third. Okay. So we established that if we pick perfect squares, we're going to have good points because the square root will be an integer. So let's get away with 2 and 3. Those are not good points, so to say. And a better point might be, what's the next perfect square? 0 squared is 0. 1 squared is 1. 2 squared is, good, 4. So 4, and the square root of 4, of course, is 2. And then 3 squared, which would be 9. And your next good point, that would be 3. Okay, so as we go to plot these points, we have 0, 0, 1, 1. Now it's important to pick enough points, because if you just see those 2 points, you may start thinking this is a straight line. But again, if that was the case, a point like a half would be a half, right? But again, we can see on our calculator that if we take the square root of a half, it's not a half. So we do have a curve going, and you are going to need to pick enough points to see it. So 4, 2, you should start to see it start bending, and then 9, 3. Okay, so it actually starts to bend pretty quick. And this is going to go like that. So ignore this point. 9, 3. Okay. So the domain is x greater than or equal to 0, and the range is also y greater than or equal to 0. Okay, so we get all positive values and non-negative values of y. All right, so what about a shift? So we have a left or right shift of a parent function will occur if a change takes place under the radical. So here we see a negative h in our formula. Well, here's a minus 2, right? So we can see that if we have x minus h, it's easy to see that h is 2. So this is going to be a shift 2 units to the right. Again, we're always going to put what's under the radical greater or equal to 0. Cool. Let's use the actual number 2. Okay, so that means that if I add 2 to both sides, I'm going to get x greater than, x greater than or equal to 0. So if I put add 2 to both sides, I'm going to get x greater than or equal to 2. Okay. So again, we're shifting 2 to the right. So our new 0, if I add 2 to that, it actually became 2, right? Well, let's see how we can solve for these good points. So we want x minus 2, which is under the radical, to equal 0. So if I add 2 to both sides, that's what I get, x equals 2. Right? So if I want x minus 2 to equal 1, if I add 2 to both sides, I get x equals 3. Okay. Now, if I put 2 in, for example, f of 2, well, that's going to be the square root of 2 minus 2, which will be the square root of 0, which is equal to 0. So that's what our first value was in our y column. And then I picked f of 3. This is going to equal the square root of 3 minus 2, which is the square root of 1, which of course is 1. That's what a y column is. So does this make sense? Yes, because we're shifting it 2 to the right. It's not going up and down at all. So actually, all these y values are going to stay the same. Okay. And what's going on in our x column? Well, again, I'm shifting it 2 to the right. So I took 0 plus 2, I got 2. I took 1 plus 2, I got 3. Guess what? If I take 4 plus 2, yeah, I'm going to get 6. If I take 9 plus 2, I'm going to get 11. Okay. So let's go ahead and plot these points. 2, 0, 3, 1, 6, 2, and 11. So let's imagine it's out here, and 3. So here we go, a shift of 2 units to the right. Not a long way. So we see here, just a bad graph. I need to calibrate. That's better. Okay, so we can see it shifted over 2 to the right. But what about shift 2 to the left? What I want to show you now is if you look at our last graph and we look at our pattern graph points, 4, 2, and 9, 3. So if you look at the difference between the points, it's 2 to the right. Right, it's 2 to the right, 2 to the right, 2 to the right. So let's see what happens if we try to look at our parent graph points. For example, 0, 0, 1, 1, 4, 2, and 9, 3. And we would actually say, well, this time let's look at a shift. We have a plus 2 under there. So this is like x minus a negative 2, right? Here, let's see. I can pick different color. So, yellow, these things are pretty good. So again, you have square root of x minus a negative 2. Because our formula has a minus sign, so we have to change this to subtraction. So again, x minus negative 2 is equivalent to x plus 2. But now if I line this up with my formula, you can clearly see that h is equal to negative 2. So it's going to be a shift 2 units to the left. Okay. So I will also take a look at my domain. Again, we want x plus 2 be greater or equal to 0. So let's subtract 2 from both sides and start with x greater than or equal to negative 2. And since it's just shift left right, my domain is not, or my range is not going to change. So I get x is greater or equal to negative 2, and I get range y is greater or equal to 0. Alright, so we have our paragraph points. We think this is going to be shift 2 to the left. So what I'm saying is, we could make a new chart, and maybe we'll check a few points. But the other thing we can do is look at each point and move it over 2 units, right? So here, if I move it negative 2, here, negative 2, negative 2, negative 2. So my claim is this is going to be my new graph, shifted 2 units to the left. Again, let's test a couple points. Let's look at 1, 1. if I let x plus 2 equal 1, that means my x better equal negative 1. Okay, so it should be negative 1 here. Okay, and then if I let f of negative 1 is going to be the square root of negative 1 plus 2, which is square root of 1, which is going to be 1. So it should be the point negative 1, 1. Is this point on the graph? Sure enough, there it is right here, negative 1, 1. Okay, so it does match up. And if I were to look at copy the T-chart, again, it did not go up and down, so this would just be 0, 2, 1, 2, 3. And again, I'm subtracting 2 from every x value. So my first point should be negative 2, negative 1, which I already saw. 4 minus 2 is 2, and 9 minus 2 is 7. Sure enough, that's going to match up with all our points. So negative 2, 0, negative 1, 1, we already saw, 2, 2, and 7, 3. Okay, great. Now for our shifts up and down, we're not going to be moving it left, right. We're moving it strictly up and down. So as you can probably guess, we're going to be copying over our x column over here. Because again, this is a shift up, not left or right. So here, the k is outside the radical. So in this case, 3, it's going to be a shift 3 up, right? So it's the same direction this time. And domain, well, this isn't affecting the x value, right? So under the radical, it's still x greater than or equal to 0. What it is going to affect is the domain, or the range, right? So now our y values all get shifted up. So our first possible y value is going to be 3. So it's going to be y greater or equal to 3. We'll see that here in a minute. Again, let's say to find a couple, just using some brute force. If I find f of 0, that's the square root of 0 plus 3, which is 0 plus 3, which is 3. Okay, so let's notice there's 3 more than it's in our y column. Okay, so I add 3 to the 1, I'm going to get a 4. If I add 3 to the 2, I'm going to get a 5. If I add 3 to the 3, I'm going to get a 6. So I claim this is going to be my shift. 0, 3, 1, 4, 4, 5, and 9, 6. Okay. Again, this is just shifted up 3 units. Again, we kind of tested a couple points out already, so I think that's sufficient. And let's go ahead and take a look at one more. So this one, we're going to shift down 3 units, right? So we can see here k is negative 3. Of course, we could write it as square root of x plus negative 3. And then your k is exactly negative 3, and so we shift down 3 units, right? Okay. So again, it's not going to move left to right. But this time, I want to take a look at moving the points. So if I graph my parent graph points, 0, 0, 1, 1, 4, 2, and 9, 3. And I'm saying I'm shifting them down 3 units. By the way, let's make note, under the radical, it's just an x, so the domain is still x greater or equal to 0. But now we're shifting it down. We're saying that y is going to be greater or equal to negative 3. Okay, so shift it down 3 units. So our 0 point goes to negative 3. Well, let's go take a look over here. So we're looking at down and down 3 units. So 0 minus 3 is negative 3. 1 minus 3 is negative 2. 2 minus 3 is negative 1. And 3 minus 3 is 0. So my claim is this is the graph, the shift, square root of x minus 3. Again, we kind of continue over here calculating. 1 minus 2 equals 0. Minus 2 equals 1. Negative 3, negative 2. It should be, 2 is 0. 3 is 1. Okay, so these are minus 3. Sorry. So 2 minus 3 is negative 1. And 3 minus 3 is 0. Sorry about that. Let me make that a little neater. So again, we're subtracting 3 from each one. So 2 minus 3 is -1. Which is then 3. -2. 2 minus 3 is 0. Alright, that's better. So we have -3, -2, -1, 0. And again, we just move our graph left to right, so it stays 0, 1, 4, 9. I'm just going to check these, right? So 0, -3, check. 1, -2, check. 4, -1, check. And 9, 0, check. So this is indeed a shift down 3 from our parent graph. All right, that is the end of part 1. Again, complete your notes and your worksheet on graphing the square root. And make sure you check out the second part, which is graphing the cube root. Thank you.